Hi, my name is Mark Prosser. Thanks for coming up to Wisconsin. We're in my little garage today, and we are going to show you how to fix a rust hole in a fender. Because in Wisconsin, we deal with the rust. They spread hundreds of tons of salt on the road every year, and these rust holes are all over the place, old cars and new. So we know you like working on your old cars out in your garage. Even your newer cars, 5, 6, 10 years old, that have rot holes in them, greatly depreciates the value of them. So few tools, few steps, we're going to show you how to fix a rust hole. So if you're going to do this kind of work, you obviously have to have some tools. The welder is going to be the biggest purchase, but that's always a great investment. We've got hand tools here. I think everything we need to fix this rust hole. First thing I love is these pneumatic saws. They're really controllable. They'll cut tight circles, good radius, but the best thing about them is that blade width. And it's only about 35 thousandths of an inch. So when you cut two pieces of metal, when you butt them up to weld them back together, which is what we're going to do today, that small curve makes it real easy to weld, as opposed to a cutoff wheel or a thinner wheel like this one in a die grinder. The little pneumatic saws are one of my favorites. We've got a little bit thicker grinding wheel we're going to finish the welds with, and I'm lucky enough to have two of them. So I have a sander on this one, but you can change these in and out, so you really only need one of these angle grinders. Next tool are our aviation snips. There's been a lot of videos done on these, how to use these, but if you notice the top jaws, one curves to the left, one curves to the right. If you're cutting to the left, you use the ones that curve to the left. A couple dollies for dollying our metal out when we're done welding it. This one I've actually wrapped a little copper around. We're going to use for a heat sink, because welding sheet metal, you know, a heat sink's good, especially for filling holes. We've got our welpers for cutting off our MIG wire, and a couple different body hammers. These things, you can buy them for 10 bucks, you can buy them for 35 bucks. They're a necessity. The other thing is a sheet metal gauge. A lot of people have never seen these, but they have a decimal on one side, they have gauges on the other side, so we can kind of match up our metal we're going to use to fix our panel. If you have a 16 gauge panel, you don't want to put a 20 gauge patch in it, or vice versa. And these cool new little magnets here for holding our sheet metal. They're small, they're easy, and they're strong. It can be hard to hold that sheet metal when you're trying to tack it sometimes. So when we're working in our garage, especially a garage like mine, which is very close to my house, in a neighborhood with lots of other houses and garages around, safety is the most important thing. Two things that are terrible is a fire in your garage or getting injured. So we're going to run through some safety gear that you need to use when you're out working in your garage. So first things first, you got to have a good coat on. You can't weld in a fleece, you can't weld in rayon, you can't weld in a t-shirt, you're going to get burned. We're going to use our welding hood. Everybody knows what these are. It's a Viking welding hood, and it's got the new digital lens in it, which I'll tell you is really cool. These also work really well for grinding mass. So if you're doing a lot of grinding, you can put these on, and they have a grind mode in them. You can put these on grinding, and it protects your face. Earplugs. I love these ones because they just ride here all day. Today we're going to do stitch welds on this stuff, and we'll get to why that is later, but we're going to stitch weld this stuff. So I'm wearing some thinner gloves, but typically if I'm going to do any MIG welding, I want to get some thicker gloves on. Second thing is, take a look around your shop. There's things that are around that, you know, those sparks from that MIG welder can jump 7, 8 foot, and they land and they burn for a second or so. Just remember, safety is always your #1 priority. So the first step that we're going to do is we need to kind of analyze this rust hole. See how much work we need to do to, #1, open it up, expose what's good metal, what's bad metal, the brace on the inside, how we're going to get that out of the way, and then repeat that process to put it back together. We're going to grind it open. We're going to make a pattern. We're going to scribe the pattern on the fender, cut the hole. We're going to get that pattern in there. We're going to hammer and dolly it around, finagle a little bit, tune it up a little bit, and get this thing welded back in. So the first thing we need to do is part of our analyzation is we got to get this inner structure out of here. This thing's got a couple spot welds down in the bottom. I've already removed a couple of them, but I'm going to show you a tool that really does well on those. But we've got to get this thing out of the way. I need to have enough room to get a hammer and a dolly in there. That's the bad part with welding sheet metal, is the distortion. You have to be able to fix it. So we need to get this brace out of here, and I'm going to do that with my saw. Once I get this brace out of here, I can start looking at this metal, get a grinder in here, clean this stuff up, start looking at this metal and see just how big of a patch we need to cut. I don't want to cut out any more metal than I have to. If it's a good metal, I don't want to cut it out. I want to get about a 1/2 inch or 3/4 of an inch from the rust. We're going to call that good. But the first thing we got to do is get this brace out of here. So first thing on the bottom of this, I've already drilled out a couple of these spot welds. You know, these things are put together with spot welds. This inner has a flange on it. It comes around and the outer skin wraps around it, and they put a resistant spot weld right on it. So sometimes if you're going to separate these, it's real hard to do. You know, if you use a chisel or a grinder, you just pretty much destroy both pieces. So what I wanted to show you is this cool little spot weld drill bit. A lot of people don't know about these. They're used extensively in the auto body industry for sure. But I'll show you real quick how these work. You just drill an 1/8 inch hole, and this thing comes in. It goes right in the hole, and this diameter of this bit is just about the size of those spot welds. So we run this thing in, and what it does is really quickly removes the outer sheet from the inner. So we can get in there with a little chisel and knock that off real easy. You can see right here where I've already done that. That does two things for me. That allows me, when I weld it back together, I have a hole that I can weld right to the inner real easy, but I also have that inner as a backing for my weld, but it's also location holes. So I know I'm putting that thing exactly where it came from. So now that we've drilled out some of these spot welds, I got 2 of them down here. I got one that wasn't lined up very good. We're going to deal with that later. I've got 1, 2 here, and this is all the farther I need to come up. So my next step is going to be, I'm going to cut this brace out of here. First I'm going to use my angle grinder, and I'm going to get in here and I'm going to grind the paint and all the crud out of here before I cut it. So we're going to grind this open, we're going to clean this up before we cut it. I'm going to make a nice little slice here with my pneumatic saw, and then I'm going to cut this thing right down here, and then we'll decide when we get there whether this thing's going to fold up or if I'm just going to get it out of the way. So the next step, we're going to cut this inner structure. We're going to get it out of the way. We've got this ground open nice. I'm going to cut this off here, and I'm going to cut these 2 flanges here, and this little area right here I'm just going to leave connected, and I'm going to try to flip this inner structure and just move it out of the way. That'll do 2 things for me. It'll make it easier to bring it right back down where it was, and I'm leaving this attached, so it's going to be easier for me to place it. So I'm going to pick up my earplugs, I'm going to cut this piece. They do 2 things. They keep the sound out, they keep the debris out of your ear too. Now I've got these 2 cuts done, and I just ran into the problem. I can't leave this attached because these are lined up, so I got to cut this thing all the way through. A little more cut. Not a big deal. We can still get it back in there. We can still weld it up good. But now my inner is removed. We pull this thing out for 2 reasons. We got to get to the back of this metal, and well, we need to deal with this too. We're going to clean this thing up. We're going to spray a little weld-through primer on here before we put it back on. Typically, if this was a restoration piece, I would probably have had this sandblasted or media blasted before we even started. But for our purposes today, we're going to show you how you can do this, get rid of this rust, and protect it a little bit. Get a little bit of a coating on there before we put it back together, so you're not fixing this rust hole again in another 2 years. So I'm going to flip this thing over, and I'm going to start with the better side. And then I'm probably going to take this thing outside to grind it. So I'm going to break this paint open. I'm going to take it down to good metal, because I just don't know how good this stuff is yet. We're going to get this stuff opened up, and I'm going to use a little angle grinder because I love these things. If you got a 5-inch grinder, you know, air grinder, electric grinder, any of it will work, but I love my little angle grinder, and I use a 36 grit disc on it. I'm going to come in here and I'm going to grind this, but one thing I want to talk about with these grinders, when you're grinding in a hole like this, you always want to make sure that you spin this disc off from the edge. In other words, these discs all rotate clockwise, and when I spin it off from the edge of that sharp metal or anywhere around that metal, I'm spinning off the edge. If I tip this grinder this way and I spin that disc into that sharp metal, this thing can catch, that metal is going to catch that disc. And these discs are real thin and they're on a rubber backer, and that can catch that, cut it, and well, at 20,000 RPMs, you got a little projectile that flies off the end of there. So you want to always make sure that you're spinning this thing off from the panel when you're going around here. And that's just a matter of angling the grinder one way or the other. Most of the time, people like to come up and angle them like this. So my contact area is only that big. But if I keep this grinder as flat as possible, now my contact area is a lot bigger. It's a lot less heat generated into the panel. You're obviously going to have to tip it up on edge, but always keep these things as flat as you can. You can cover more area, it's more uniform. And if you notice, no matter how I'm going around this thing, my disc is always spinning off the metal, never into it. So we've got it cleaned up pretty good. Good thing is, we've still got a lot of really good metal here, right? I mean, I got down on this pretty heavy with a grinder, and there's some little pits in there, but I think it's going to work. So for what we're doing today, if this was a little bit worse, I would just make this whole panel, make this patch come all the way down with the flange, the whole deal. But I think we're going to skip it. I like this ridge right here, and I like this ridge right here, because this hemmed edge and this ridge are going to give us a whole bunch of strength to weld to. We get that new patch in there, there's not going to be any distortion here, or very little, and very little here. So the only distortion we're going to have to deal with is this. So, you know, I'm just going to take my soapstone and just kind of do an idea. We said like a 1/2 inch to 3/4 of an inch around the panel, around from the edge of the rust. And I'm going to cheat just a little bit and try and keep it right onto that edge there. And that's about how big my panel is going to be. What I do next is I use a piece of cardboard, because it just happens to be what I have laying there. Chipboard's a little bit thinner. It works a lot better for making patterns. But I'm just going to come in here and I'm just going to start making a pattern that I can transfer. We're going to have to shape this metal a little bit before we put it in there, and we're going to always round the edges. You always round the corners when you weld patches, and never use square corners, and I'll tell you why when we get a little bit further along. But basically, when I start with these patterns, you know, I just come in, I start making a few marks here and there where I'm going to be with it, and you always make it a little bit bigger, because obviously it's easier to make it smaller than it is to make it bigger. So I'm just going to come in and rough cut this stuff. I'm going to come in and just try and tighten this corner up a little bit. I know I want my corners radiused. This helps distribute the heat when we weld it. If you weld a sharp corner, all the heat gathers in, it'll distort a lot more. This thing I actually end up with big divots right in the corners if we use square corners. So you never use square corners on your patches. A lot of times people go in and they cut the hole out first, but it's a lot harder to build a pattern that fits the hole. So we build the pattern first. I'll make the pattern, I'll transfer it to my metal, I'll cut it out on my metal, I bring my metal over here, then I'll do a tight scribe around my patch, then cut the hole out. Sheet metal is not just sheet metal. If you look at this, we've got gauges on here, so if I find a spot on this fender and I check this, after I knock the paint off a little bit, that's 18 gauge sheet metal. So I don't want to use 20 gauge on it. What I've got here is a hunk of scrap, and it is a little bit bigger than 18 gauge, but not enough to make a difference. It's actually about 17 gauge, but close enough. A little bit thicker than the base metal. 1 gauge thicker than the base metal, that's perfect. So we're going to transfer our pattern to our metal. So now we've got our pattern made. It's pretty good. It's probably 3/4 of an inch around the rusted areas of the metal. So it's not that important that I make this a real tight mark yet. Where it's going to be important to get a nice tight scribe line is after I've made my pattern, I bring it back over to the fender. So we're just going to go around this pattern with a Sharpie. Because if the distance of the pattern's a little bit bigger, it doesn't matter that much. The next step when I trace the pattern out on the fender is where it's going to matter a lot. So we're going to make this cut here. Okay, so now I'm going to cut this thing out. Depending on what tools you have, obviously. If you got a Beverly shear, those are really nice, but they're about 500 bucks. Don't happen to have one. I could cut it out with my pneumatic saw. I could do it that way. But my weapon of choice for the moment is going to be the aviation snips. I'm going to do a rough cut around this edge, and then I'm going to come in with just a little bit left on the edges like this and tune this patch up real well. So I've rough cut this thing out. Now I'm going to come in here. It's just going to be a lot easier for me to get it to good tight cut. Again, this is just a rough line. I don't need to worry about it. I just want to make it symmetrical. I'm going to use this straight edge. That's going to come up on this side. And I'm just going to come in here and tune this piece up a little bit. Round corners. It doesn't matter if it's off an 1/8 of an inch, 1/16 of an inch. Just doesn't matter at this point. So now we've got a pretty good patch. I'm going to get my grinder out and I'm going to smooth these edges up. Just make them nice and round. I've got to weld it up. But if you notice, this is flat. This fender is not flat. It has a contour to it. So a great way to see that is with a piece of sheet metal, flexible sheet metal. And we can just take this and see that contour. And I'm just going to take this and I'm going to put my little marks on it. And here's what I'm going to start with. I'm going to do what we call registration marks so we know we're getting this thing back in the same spot every time. So I'm just going to put a couple marks here. And a couple marks down here. And a couple over here. That way I know when I pull this thing off and on and off and on, I'm getting it back in the same spot on the panel. But I need to make this thing take the shape of this a little bit better before we do anything else. So if we look at this metal, obviously it's flat, right? We have a straight edge, it's pretty flat. This stuff is flat. We've got to make it contour to this shape. So depending on how strong your hands are, sometimes I have luck with this and sometimes I don't. But if I just flex this thing in my hands a little bit without my English wheel and my big pull max hammer, if I just flex it in my hands a little bit, look at how much shape I've already got to this thing. It's easier in the middle, so I'm coming to the edge. I'm just going to come up here and I'm just going to bend this over a little bit more. And you slide this over, bend it down a little, nice and easy, so we're not kinking it. And then it's a good start spot. I can already see the shape in it, right? So I bring this back down. Holy smokes, how'd that happen? No, it's not perfect, but we're close. We're close. It's got a little bit of a twist in it. And I do realize that if you don't have your man strength yet, and building these patches with your hands might be a little bit tougher. But if we look at this, I'm pretty good. I got a little bit more here. I put this back in my same spots. I think I can make this work. When I get in here and start tacking this a little bit, I can flex it around too. So I think I'm going to make this work. And the next step is going to be to scribe around this patch, and that's the important one. We got a good line here. It's one nice scribe line. I'm going to come in here with my pneumatic saw and I'm going to rough cut this area out And then probably how I'm going to get in real tight is with my aviation snips again, because that's very controllable. So I'm going to rough cut this out with the saw, and then I'm either going to decide to make a nice saw cut or I'm going to do my aviation snips. But we are going to get this rust out of here. So we've got our hole cut out, and unfortunately it didn't go quite how I liked it. If you look down here, I knew this was cracked, but the metal's still good, but it was cracked, probably from flexing, but as soon as I cut through it, we broke this thing loose. So, not the best case scenario, but certainly not the end of the world. I mean, it's metal. You have a welder. You're welding. Weld it, okay? So what I'm gonna do now is I got my cool little magnet on here, and I'm just gonna keep fitting this thing until I get a nice little butt weld. Now some people, when they fix this kind of stuff, they'll stick that patch in behind and weld it up as a lap joint, or they'll lay it right on top and weld it up that way. I don't prefer to do it that way because you can't do anything with the distortion. It gives a bigger ridge, therefore you have to use more filler. So whenever we do these, I like to use butt welds. So I'm just going to sit here and I'm going to come in here and look at my cut's pretty good, but I'm just going to tune this thing up with my little angle sander just a little bit. And I'm going to make my way all the way around that patch till it fits my hole real nice, just how I want it. I keep lining it up in the same spot, and my whole intention with this is how is it going to weld? How good can I weld it? At this point, the better the fit up, the better the weld. You have to have a nice tight fit up when you weld this sheet metal. The bigger the gap, the bigger the weld, the more distortion. You can't weld a great big gap. You got to get it nice and tight. So I'm just going to tune this thing up. And I will also look at this, and any of these frayed edges, any of these funky edges, just going to flatten these things out. Because folks, it's all those little details that make the whole patch go in there nicer. You get all this stuff in line and the weld goes in, distortion is minimal, we can finish the weld nice, which creates a lot less finish work for us. So we're just tuning up this patch and we're getting close to start tacking this thing in. So today we're using the new Lincoln 210 MP, I would say MIG welder, but this thing is pretty cool. It's a constant current, constant voltage machine. So we can MIG weld with it, you can TIG weld with it, you can flux core with it, and you can stick weld with it. All in this small compact unit. It's an inverter, it's about 40 pounds, very cool machine. So we're going to show you how to set this thing up for what we're doing today. This is like our home settings here. It's a very simple, we're plugged into 120 into the wall. We have a 220 over there too, but we're plugged into 120. We're MIGging steel, we're using an argon CO2 mix, or we can turn to 100% CO2. We can go to manual CV, so we can adjust the voltage and the amperage however we see fit. We go to flux cord, spool gun setting, stick, TIG, and other settings that you can set for each one of these. But it's pretty impressive. Small machine, constant current, constant voltage, does it all. So we're going to take a step into it deeper. We're running 75-25 cover gas. We push the button. This is showing us that we are running direct current positive, electrode positive. We MIG weld in DC EP, except for some flux core wires, MIG weld in DC electrode negative. But today we're running solid core wire, solid wire. We're running positive. We're running 025. We got 030, 035. We're running 025. I set it up. It gives me gauge thickness. I go all the way from 12 to 24 gauge. So we're at 18 gauge. We're running 18 gauge. I push it in and it gives me operating voltage and amperage. Here's the cool part. It's in green. I can fiddle with it a little bit to dial it in how I like, but when I get out of parameters, it turns red and it says, wait a minute, you're too far away. Okay, same thing over here. So you can have a little bit of an adjustment. And that's really good because This welding stuff's a lot like science, right? You have to have these things in parameters for it to work. We can move around a little bit, but they've got to be in the range. What I found out doing this example welds the other night on the 18 gauge was this though. I know that I'm going to be pretty much stitch welding this. Some people call it a triggering weld, stitch weld. I'm going to be on and off the trigger. So what I found was this setting here for 18 gauge, 16 volts and 154, it's pretty close. But the welds we're going to do are essentially a series of tacks. And if you're making a weld at these settings, it welds really nice. It makes a nice little weld on your 18 gauge. But I want a hotter weld. I want a nice instant hot weld that's going to fuse those pieces, because the faster I can make that weld, the less distortion I'm going to get. So what I found is, just a little bit of examples on my own, what I found is if I run this up to about 230, which is in the red, I get a hotter, faster tack. It's a lot hotter, faster tack. So I'm going to run about 16.7 and 230, but I don't like being in the red, so here's what I'm going to do. I'm going to go back, run through this again, and I'm going to go, instead I'm going to try 16 gauge. Now we're welding 18 gauge, but I'm going to do it for 16 gauge. Now I'm up in that area where I want to be, because this thing for me just seems to give me a much more instantaneous tack. It's a nice round tack and it happens faster, and I know that that's going to put less heat into the panel, which means less distortion, and that's what we always want. So we're getting ready to weld. We want to remember our safety stuff again. Fumes is a big concern. You know, we're going to use a little mini flex portable fume extraction unit, because we're in a small garage, we have short ceilings. You know, I could kick the door open the window, put a fan in, but then you have problems with cover gas. So we're going to use this little fume extraction system. You know, we're going to have our clothes buttoned up. We're going to use our welding hood, eyeglasses on. They need to be on underneath your welding hood too. Gloves. Keep your head, if you can, for the most part, out of the smoke. We've got this cleaned up good, but these things still generate fumes, so you gotta stay away from the fumes. So it takes a little more time, but especially when we're doing these stitch welds, it's really good practice to get into snipping the end of this wire off every time. When you stop welding, that gets that little ball on the end of there. It's also a little silicone deposit, and you come down and the arc doesn't ignite as good. So every time you stitch, it's kind of a pain in the butt to do that and snip it off, but you'll get a lot nicer tack welds. So I've got this thing set to the factory setting. I've increased the wire feed speed, amperage, more heat, a little bit, but we're still in the green area, but we're set for 16 gauge. We're welding 18 gauge. So we're going to see how it sounds. You know, the old fry and bacon thing. We're going to see what our tacks look like, see if we're ready to go. We got a nice looking tack. Little spot on the back side of penetration. This thing flows in real nice. I like it. I can work with it. So our machine's set pretty good. We're going to get back into fixing this spot down here, and here's what I'm going to try. I've got this dolly wrapped in copper used for heat sink. So I'm going to come in here and I'm going to get this thing sitting tight. Nice tight fit up. I'm going to get the copper tight behind the thing, and I'm going to put one quick tack on here and see if we can fix this. Took a few more than one little tack, but with this heat sink, it worked awesome. We got this back attached, so we're back in business to fit our panel in there. I'm going to just tweak this a little bit more, tune it up, get my hand file out possibly, or my sander, and I'm just going to get this thing, and I'm going to take the time now to get this thing fitting the best that I can, because I could probably stick it in there right now and start welding it, but it's not going to weld as nice. I'm going to get more distortion. I'm going to have a lot more finishing to do. I got this panel. It's going to sit right down in here nice. There's a couple spots, a couple small spots that are a little bit bigger gap than I'd like, but I think with my trusty heat sink, we're going to be okay, right? So here's what I'm going to do to start this. It's real hard twist-wise to get this, so what I'm going to do is I'm going to pick a spot on the top and I'm going to put one tack on here. That way I'm attached, and then I can move this thing around and I can twist it side to side to make it fit better. So, first thing I'm going to do is just hold this thing in my position and I'm going to put one tack on here. Okay? We got one little tack, and now I can move this thing around. I might need to hammer and dolly a little bit, but I really want to take my time and make it fit nice. So I'm just going to go around this whole thing, and every place it fits really good, I'm going to put a tack. Right there it's nice and flush. I'm going to put another tack. Nice quick tack. I'm going to come up here on this side, put a little tack. I've got a pretty good fit up, but what I'm doing is, this is new metal, this is old metal, and we already established this is a little bit, just a little, 1 gauge thicker. So what I'm doing when I tack this is, I'm starting on the good metal, and I'm just washing it over into that other metal real quick. So I just keep working my way around. This is nice and flush. I get a tack here. Now some guys will go through, and I'll probably do this when I'm done tacking this piece in, and dolly all this flat to make sure we're sitting good. But we're looking pretty good. I'm going to come over to this side. Just nice little tacks. Because you don't know, you might have to cut this stuff back off. You don't want to weld it in, right? Another little tack. And I've got a little bit of a gap down at the bottom here, so I'm just going to bring this up with my dolly. Gentle. It's just sheet metal. I'm going to get that nice fit right there, and I'm going to keep working that as I go around. Nice little tack. So you notice this is a little bit lower. I'm going to come in from the back side. That's why we removed that inner brace. And I'm going to bring that dude out flush. And man, we're looking pretty good. Now being as this gap's a little bit bigger, I am going to use my heat sink on here. I love these things. So I'm going to pull this in behind. Nice little tack. I'll put one more down in here. I'm checking flush. If anything, we're going to come over this with some lightweight polyester surface enhancer, also known as Bondo. We're going to come over this, so if anything, this patch should be a little bit lower. You don't want it sticking out at all. Keep it down. This is fitting pretty good right here. Now I notice that this is a little high here, so I can get in here with my dolly. Take that down just a little bit, and man, I think we're sitting pretty good. We're going to do these stitch welds with this MIG because we're going to do our best not to distort it, or at least the smallest amount as possible. So I'm just going to start working my way around, and I'm always checking to make sure this is fitting flush, and if it's not, I can give it a little tap. It's always good also to move around the panel. So stitch it here, come down here, come over here. That way we're not building any heat in this thing. I mean, I've got these thin gloves on and there's no heat at all in it yet. So, and that's how I want to keep it. We're just going to keep walking around this thing. We're going to dolly the pieces flat and we're going to keep connecting these until we get it all welded. So we got this dude welded up. Took a long time, a lot of little stitches. But man, I got to tell you, it's pretty good. It's pretty good. There's not much distortion at all. I'm going to knock these welds down a little bit and then I'm going to show you. I just wanted to show you when you get into doing these welds, what a lot of people do is they'll take this grinder and they'll go back and forth across this weld. So what that does is it dags into the base metal on both sides of the weld, humps up over the weld, and hits the other side. So by the time you get the weld down, sometimes you can cut right through the base metal right at the toes or the edges of the weld. So if you take that grinder and you turn it just a little bit on that weld, you can really control where you're grinding. And what we're trying to do here is just take that weld down a little bit. I'm going to knock the tops off of all of this, and then we're going to check the shape. See how much distortion we actually ended up with. So I'm going to knock these welds down a little bit. We're going to check the shape with our straight edge. And then if we got to do some hammer and dolly work to tune it up a little bit, we can. But I think you'll find once these welds get knocked down, a little bit of that plastic filler. Some guys call it healing salve. It'll be just fine. So let's knock some of these welds down. So with that little angle there, I'm only touching the weld. If I go back and forth across this, now I'm cutting into the base metal on each side of the weld. So I just use a little bit of an angle, just a little bit. And I can knock that weld down pretty nice, pretty flat, pretty fast. Even a little bit wider grinding disc, like maybe 1/4 of an inch, about the width of that weld, will work even a little bit better, because then you're just touching the weld. So I'm going to finish grinding this up. We'll check our contour, see if we need to hammer and dolly a little bit, stretch that stuff back out, get it back in place. For this project, if I can get this within 1/16 of an inch, especially MIG welding this in, I'm going to call it good. So check it out. We take a little measurement of our contour where the metal's still good, and we bring it over to our metal, and if you can see that, I'm going to say it's less than 1/16. It's definitely an honest 1/16 all the way down. If I look right at the beginning, right in here, it's still only about 1/16, but we're going to see if we can close that up just to show you how this hammer and dolly works a little bit. So we're going to leave that just like that. I'm going to come in with my hammer and my dolly. I'm going to put my dolly on this side. Be gentle, it's sheet metal. Just a little bit of tap. Let's see what we get. All right, I'm going to roll a little more. And look at how much we close that up. So if you can see that gap, we closed it up a lot. And it just took a few taps. And that's how we want to do this, because if we take this thing, right there's the worst of it, and that's about 1/16. I'm calling it good. If we take this thing and we keep working it on a hammer and a dolly, we're going to stretch it out and stretch it out. Then we put our filler in there, we're going to have a high spot in it, we're going to have to beat it back down. So it's best to leave it just a little bit down. But I think we're doing pretty good. So we've got our patch ground on the inside. It's pretty nice. You know, if we're going to restore this fender, obviously we're going to go to get it sandblasted, media blasted, whatever, start fresh and new. But we got to put this piece back on here. I've done the best I can with a wire brush to clean this up. The important thing is to get some weld through primer in between these two pieces where they made up. Because even when we weld this back in, we sandblast it, we prime it, we paint it. It's awful hard to get the paint back in beside them. So what we've got is some weld through primer. This is a copper weld SEM product, but it just takes a little bit. It's just a barrier between the back of the metal where you're not going to get any primer or any sandblasting down in there. Just a little bit, and I'm going to put a little bit on the back of this, and we're going to call it good. So, we've got a little bit of weld-through primer on here, right? Just enough. Didn't make sense to put it back together without any weld-through primer. If we're going to restore this thing, we're going to get it all blasted, start from scratch anyway. But the cool thing about the way we cut this inner out is, you know, I can look at this and really take your time and tell exactly where this is going to be. So this thing needs to lift up about that far. And that means that fender needs to come up to catch it. So it's going to put the bottom of my fender right where it needs to be. If I just lay this thing in here and weld it up like that, my fender's going to kick out at the other side. So we're just going to put a couple tacks on it here, and I'm going to take my time and I'm going to get it really nice, the best that I can. So I've got the brace tack back in there. It's not welded up yet. We'll do that in a little bit later. But on the bottom with these plug welds, if you can see this plug weld, that's why these plug welds are so cool to drill out with that bit that I showed you, because I can line this right back up where it came from. So how I'm going to weld this in is I'm basically going to start in the center of that plug weld just off to the side. I'm going to let my puddle build up, and I'm going to go right around in a circle and just let it fill up with weld. So let's give it a shot. Ready? I think if you can take a look at that, we're right back in the same hole. Pretty flat, pretty easy to finish. I can even use my little copper bar. Let's run these other ones shut. We've got our piece tagged back in. Everything's where it needs to be. So I hope you enjoyed the rust hole fix. I'm Mark Prosser for ARC Magazine.